Good morning, everyone. Today we're going to be doing experiment 15, which deals with stoichiometry and determining the yield of a chemical reaction. The reaction we're going to be doing today is one between copper chloride and magnesium. And what we're going to do is we're going to measure out a certain mass of the copper chloride and then convert it to copper metal, and we will weigh the amount of copper metal that we get, and then using stoichiometry we can calculate how much copper we should produce in the reaction, and we can compare that to what we actually get, and from that determine a percent yield. Now, one thing I should point out that's different than the lab experiment is we're using copper chloride hydrate. It actually, the molecule or the compound has two water molecules attached to it. So this is known as a hydrate. If we remove the water, we would have what's known as anhydrous copper chloride. So when you're doing your calculations, be sure to add the mass of the two water molecules to the two chlorine atoms and the copper atom in doing the calculations. And I'll be doing a short little pre-lab video after our introduction here, and I'll go over that with you just to make sure you're clear on that. So the procedure is pretty straightforward. We're going to measure out a mass of the copper 2 chloride dihydrate. The lab says to use a 50 ml beaker, but I find it's a little easier to see in the video if we use a 50 milliliter size test tube. It'll be easier for you to see what's happening during the course of the reaction. So we'll put the copper chloride into the test tube. We're going to dissolve that in some hydrochloric acid. And then we'll simply add magnesium ribbon or magnesium pieces to it. And that magnesium is going to convert the copper ions into copper metal. At the end of the reaction, we'll simply wash the product, which will simply be copper metal. We'll dry it in the oven, and then we will record the mass. And we'll go ahead and do this 2 times today, because whenever you're doing an experiment like this, it's a good idea to repeat your results. So go ahead and watch my pre-lab video, and then we'll head on over into the laboratory and begin the experiment. As I said in the introduction, the goal of this lab is to figure out the percent yield of a chemical reaction. And just as a refresher, to calculate the percent yield, we need to know 2 things. We need the actual yield, and that's what we're going to be doing in the lab today. We're going to carry out the experiment, collect our product, and weigh it. We also have to get the theoretical yield, and for that we're going to use stoichiometry. We're going to calculate what's the maximum amount of the copper that we could get in the reaction today. And of course, we always multiply by 100 to get a percent. This is the reaction that we'll be doing in the lab today. We're going to react copper 2 chloride dihydrate with magnesium to convert the copper ions into copper. We're going to carry out the reaction in the lab and weigh the amount of copper that we get from the reaction. And we'll also use stoichiometry to calculate how much copper we should get from the copper chloride that we started with. So for our percent yield, again, we need these 2 things. The actual yield, of course, as I just said, will come from weighing the copper. We're going to actually do the experiment and weigh the copper that we get. And of course, for the theoretical yield, we're going to do a stoichiometry calculation, just like we've been doing in class. So we'll begin by weighing out a mass of our copper chloride dihydrate, and we're supposed to weigh out between 0.75 and 1 gram. We then need to convert the grams of the copper chloride into moles, and for that, of course, we'll need the molar mass of the compound. We can then convert that to moles of copper. We can see that there's a 1-to-1 stoichiometry between the copper chloride and the copper. And then finally, using the atomic mass of the copper, we can figure out how many grams of copper will be produced in the reaction. Let's go ahead and run through a hypothetical example here just to show you the type of calculations you'll need to be doing today. So let's suppose we weighed out a 0.84 gram of our copper chloride dihydrate. We're going to put that in a large test tube, as I showed you in the introduction. We'll start out adding about 5 milliliters of hydrochloric acid. If we need more, we can do so, and we'll end up with a lovely blue solution. We're then going to use stoichiometry to calculate how much magnesium we would need to convert all of the copper chloride into copper, and then we're going to weigh out about 1.5 times that much. We want to make sure we have plenty. An excess of magnesium is not going to hurt anything. We have to make sure we have enough, however. And we're going to continue adding that to the solution until the blue color of the copper has disappeared. It'll be replaced by a pile of copper-colored solid. We'll then rinse and dry the copper metal and weigh it, and that weight, of course, that will be our actual yield, the amount that we obtained in the reaction. So let's go ahead and see how the calculations are done. We've got our balanced equation again. The first thing we'll need to do is to figure out how much magnesium is going to be needed in the reaction. We'll take our grams of copper chloride and once again convert it to moles, but this time we're going to go from moles of the copper chloride to moles of magnesium, and that is also a 1-to-1 ratio. And then we'll multiply by the atomic mass of magnesium, and that tells us that we need about 0.12 grams of magnesium. So we're going to want to increase that by about 50%, and we'll want to weigh out about 0.18 grams of magnesium. So in a beaker, we'll weigh out approximately that mass of magnesium. We've got our 0.84 grams of the copper chloride in our large test tube, and we measure out 10 milliliters of hydrochloric acid. We'll start out using just about 5, and we'll add more as needed. First, let's calculate the theoretical yield of copper. So we start out with our 0.84 grams of the copper chloride. Once again, we'll convert that into moles using the molar mass. We can then convert the moles of copper chloride to moles of copper, because again, we have a 1-to-1 ratio between the two. And then using the molar mass of copper, we can determine that 0.32 grams would be the theoretical yield of our reaction. That's the best we could do if everything worked perfectly. And of course, everything never works perfectly. Now we need to get our actual yield. In the lab, at the end of the reaction, you're going to find we'll have a pile of copper metal, pretty much a powdery form of copper. The blue color of the solution, as you'll see in the upcoming videos, will have disappeared. And we'll want to rinse and dry and then weigh that sample of copper. And let's just suppose in this particular case, we got about 0.30 grams of copper. This is our actual yield. Then we want to calculate our percent yield. That is the goal of the lab. As we said before, the percent yield is simply the actual yield, in this case the 0.3 grams, divided by the theoretical yield, which we calculated using stoichiometry. We simply multiply that by 100, and that gives us our percent yield. So why don't we head on over into the lab, and I'm going to run a couple of trials of the experiment. I want you to record your observations and write down any of the measurements we take, the masses that you're going to use in your final calculations. And then you need to calculate the percent yield for the two trials and go ahead and answer the questions at the end of the lab. All right, let's go ahead and begin our first trial. So the first thing we need to do is to measure our empty test tube to get the mass. And we're going to use this Erlenmeyer flask simply to hold the test tube. So I'll put it on the balance and just go ahead and tear the balance back to 0. And now we can put test tube number 1 in here, and we can record the mass. Once we've recorded that mass, we can go ahead and weigh out our sample of the copper 2 chloride dihydrate. So to make that easy, let's simply go ahead and tare the balance back to 0 again, and we want to measure out approximately 0.75 to 1 gram. So let's go ahead and put some of this in here. All right, that's almost half a gram. Just a bit more here would be good. There we go. It's all right that we have a little more than a gram because the dihydrate version of the compound actually has a higher molar mass, so having a little bit more will probably be better for us anyway. Let's go ahead and get the mass of our second test tube. So we'll put the Erlenmeyer flask on and tare that again. And now we can get the mass of our second test tube. So make sure you record that. And then we'll go ahead and tare the balance once again and add about a gram of the copper chloride to this test tube. Yeah, that's pretty close already. We had a little bit more in there. Yeah, that looks good. That's just about a gram again. Next, we'll need to weigh out magnesium to react with the copper. And you need to use the stoichiometry that we talked about in the lab and also in my pre-lab video. So you should be able to calculate how much magnesium should be required for each of the trials. I've done that calculation, and it does say that we're to weigh out approximately 1.5 times what we've calculated. So we'll go ahead and do that. I'm not going to tell you the stoichiometric amount that I actually got. I want you to figure that out. So let's tare our beaker. And now let's add, my calculations tell me a little less than 1/4 of a gram should be required. And there's about 1/10 of a gram. And that should be good. That's just about right. So go ahead and record the amount of magnesium we're actually using for the first trial, and then I want you to calculate the stoichiometric amount, what should actually be needed. Let's go ahead and measure out the magnesium now we'll need for the second trial. Because our sample of copper chloride was a little bit less in the second trial, this time I calculated we'll need around 0.2 of a gram or so. And of course, again, I want you to calculate the actual stoichiometric amount. So as we did before, let's go ahead and place our beaker on the balance and tare that. And then we'll go ahead and weigh out approximately 0.2 of a gram of magnesium. We're getting close here. All right, that should be good. So again, record the amount of magnesium we've actually weighed out, and then I'll have you use your stoichiometric calculations to figure out how much magnesium should actually be required for our second trial. We have our magnesium, our copper chloride sample, and our hydrochloric acid, so we're ready to begin the reaction. Next, we need to dissolve the copper chloride in between 5 and 10 milliliters of hydrochloric acid. We don't want to use more hydrochloric acid than we need, so let's start out with maybe about half of that, and we'll see how that goes. All right, that's about 5 milliliters. So we want to swirl that around a bit. See if it will dissolve here. And if we need more, we'll add it. So I'm going to pause the video for a moment, and we'll give that a little bit of time and see if it dissolves before we add any more acid. It looks like that 5 milliliters of hydrochloric acid was sufficient. So now we're going to start adding the magnesium. We'll begin slowly with just a couple of pieces and then observe if the reaction is taking place. Oh yeah, absolutely. You can see the reaction going on there. And what we're looking for is that green color to disappear, because once the copper ions have been converted to copper metal, the solution should be colorless. All right, add a little bit more here. It looks very dark, probably due to the solid copper precipitating out of there. Go ahead and swirl that around a little bit. All right, we'll put a little bit more magnesium in here. Well, it still seems to be reacting pretty vigorously. Let's pause a moment, let that finish reacting. It looks like the color is all gone. You can see the sort of copper color in the solution now, just solid pieces of copper. There's still some bubbling going on with the magnesium. We want to make sure all the magnesium, any that's left in there, is completely destroyed. So we'll probably add a little bit of additional hydrochloric acid just to make sure all the magnesium is gone. So we're going to let that react for a bit until there's no more bubbling. Then we'll know all the magnesium is gone, and we can go ahead and collect our copper sample. It looks like the reaction is completely done now. The copper metal has settled to the bottom of the test tube, so now we should be able to go ahead and pour off the liquid and rinse off the copper metal, and then we'll go ahead and get that dried in the oven and get a final mass. All right, let's go ahead and decant off the liquid as carefully as we can. We'll try to keep all the copper in the test tube. We might lose a little teeny bit, but that's pretty good. So there's our copper. Now we need to go ahead and rinse that, so we'll rinse that with some deionized water a few times. Make sure we get rid of any additional hydrochloric acid. And we'll swirl that around a little bit. And then we'll decant that off again. And we'll do one more rinse just
to be very thorough here. There you can see it. Copper looks lovely there. So we'll rinse that around again. Get any hydrochloric acid out of there that we can. Try to get as much water out as we can here. Great. And now we'll simply go dry this in the oven, and then we can get our final mass. Our first sample of copper is now completely dried, so let's weigh it and see how much we got. So first, we'll go ahead and tare our Erlenmeyer flask. And now we can get the mass of the test tube with the copper. And then we can subtract our original mass of the test tube, and that will give us our grams of copper, and from that you can calculate the percent yield. Let's go ahead and begin our second trial. Once again, we'll add about 5 milliliters or so of the hydrochloric acid to start. Let's see. Yep, that's about 5 milliliters. So we're going to give this a little bit of time and let it dissolve. And then we'll come back in just a moment. Well, it took about 1 more milliliter of hydrochloric acid, but all of the copper chloride has dissolved. So now we can go ahead and start adding the magnesium slowly here, as we did in the first trial. Put a couple of pieces in there. So as before, it's going to take a while for all of this to happen. So rather than show you the entire procedure again, why don't we come back in a little while after the magnesium is finished reacting, and then we can proceed to collect our copper. It looks like the reaction is completely done now. So all we have to do is rinse off our copper a couple of times, and we'll get this sample dried in the oven, and then we'll wrap up the experiment. Now let's go ahead and get the mass of our copper in the second trial. So again, we'll go ahead and tare our Erlenmeyer flask, and that will give us the mass of the test tube and the copper, and then you can subtract the original weight of the test tube, and that'll give us our grams of copper for trial 2. And that should be all the data you need to complete the experiment.